Are we live? And is the voice fine now? Yeah, we are. Okie dokie. So, today we are going to try out the Rust based kind of OS, or they call it concurrency framework for the embedded systems. So this is kind of Rust equivalent of free RTOS that basically gives you a way to schedule tasks that you wish to run on your embedded device. So we are going to try it out by modifying our existing example that we have and that we've been working also on so far. So previously we used the interrupts to drive our LED to drive the flashing of our LED, and we have a song played from our our PWM output on channel 1. Yeah, so I guess let's just get to it and start modifying this to utilize the RTIC, real-time interrupt-driven concurrency framework. Okay. So let's see what's available here. Oh, should we be adventurous and go with the very latest one? Yeah. Okay, I guess let's try it. So is this called Art? No, it's called Cortex M RTIC. We will need to turn this, so we won't have this anymore. This is going to be an init. And this is going to be an up. If I remember. That's what it was missing. So we have this. Our interrupt handling routine from now on, it's going to be a task. And the most important part, we need to specify the macro here. Our device though is the STM32. let's see how are we going. Oh, that's what it is. Okay, let's allow the Rust analyzer to process this. There it is. Okay, let's see how we're doing. Expected mode. So this tells me that by using the alpha release, we went a little too far ahead. So we are essentially so cutting edge that we're using undocumented stuff. Okay, since we're trying it out anyway, and that's going to be the latest version anyway, we might as well see how far we can go with this, and then do it like that. Okay. So why is this incorrect? Yes. So by specifying different functions, as init we need to adhere to the expected signature. So context okay, and that needs to return late resources. And we need to return it then. So we cannot run an infinite loop in our init function. So that means we need to run an idle task. And we also need a specific this item must, that doesn't seem right. I think we're just missing correct signature, so it's idle, so it can never return. And again, it needs the context object passed to it. There it is. So it's the same with this. We'll look at the task in a second, I guess. Unused, blah blah. Okay, so we need to have a look at that right now. So context is team3 context. The task needs to bind, I believe, hardware task binds URT, but in our case we need to bind it to the team tree. There it is. And basically the way you're specifying, so right now those obviously are unknown. So actually let's start cleaning this slowly. Okay, so first thing, we have the device, fail to resolve. That's in the mode app. So we have to import it correctly, I guess. Mismatch types expected struct. Yes, so we need to return the late resources as we promised in the function signature. Okay. So those guys. So those are Cortex and Core peripherals. So those are coming from the context now. Core and device. So this is equivalent of our pack stuff, and this is the Cortex M peripherals. So core. And this is going to be device. Okay, we'll see in a second. All of this is missing. And let's clean up what we can. We won't be using this anyway because RTIC offers a completely different method of sharing the resources. Oh, sorry. Yes, that's because this is a module now. And all of our imports are outside of the module. So we in fact have to import them within the module. But let's see. We won't need this, nor this, nor this. And the same here. Because the entry, the function int is going to be marked as the entry by the RTIC. Okay, and that seems to be okay. That seems to be helping. I don't think we need this. Constraint expected 0 arguments. Found one. I don't think that's right. Okay, we'll see in a second. So we have this. We have idle. Yes, the cat song is outside of the module, but we'll comment it out for the time being. I guess I want to be able to compile the examples first. We won't need this either. Nor this. Because we're going to use the inbuilt method of sharing the resources, which is by specifying resources. Which is by specifying the resource that we're going to pass into the handler. So in our case, the resources are going to be the LED and the team tree. Actually, yeah, team. This resource have not been declared, and you declare those in the resource object. So our LED PC 13 output push-pull, and our team, which is countdown timer. What was it? Team 3, I guess. So then we have LED and then team 3, or we named it timer 3. This resource has not been declared. Let's see why. Struct resource. Are we getting into some sort of issue with it being the latest version or something like that? Because we have to use mod, so is there some documentation issue here? Because if yes, then we might be in for some fun while trying to track it down. Come on, RTIC. That's definitely here, LED, with the correct type. Okay, let's dig around. We are have two examples. There it is, resources. Boom. There it is. So now we just need, so we're binding the task to the peripheral. So maybe like that. No variant associated item in the current scope. Oh. There it is. Yes, so we need to obtain the lead from the context. Like that. Ah, yes, because it gives us as a mutex. So like this. Oh, yeah. Like that. And I guess the same for the timer. Oh man. Okay. More progress. Oh, actually, so this expects 0 argument. Let's see if we get more information. Okay, that seems like a Rust analyzer error. Let's do a full build. And in the meanwhile, we just restart the Rust analyzer. Okay, but we're going there. or we're getting there even. Okay, so we have the resources specified. We initialize them in the init section. Oh man, what are you up to now? So it is a Rust analyzer problem. Mismatched argument count. Expected 1 argument, found 0. But no error during compilation. Okay, we clean this all up. And we will try to see what's the issue here. Okay, once more. Okay, it's back. However, it's not reporting about the warnings anymore. So I think that our Rust analyze, there it is. Just took its sweet time. Okay, so this is never used, that's true. So let's change it to this. We don't use this inside the module. We will be needing this for our tone library, which is going to be needed in here. But anyway, right now we have the interrupt that should be handling our LED flashing. So let's try it actually. So we will try to load it into our board. Boom. So we have our LED driven by the RTIC. Okie dokie. So we have that, but we want our full example running. So we need to add the PWM stuff as well, or the tone generation stuff as well. So that means we need to pass the PWM resources and the delay into our idle task. So our interrupt task, or the timer tree task, that's done and dusted. So idle. So I'm guessing that should be similar here as well. Ah, come on. And we will need the PWM and delay. Unexpected argument. So it's not the same. God damn it. Why wouldn't it be? The app attribute in it. resources. Each context must declare the resources, even idle. I don't think they would change something like that in that alpha release. Oh, resources. Boom. And that means that we are missing our resources here. So PWM, which is the there it is. And we need a delay, which is just delay. Yes, that's what I was afraid of. I don't. The generics. So we will need to specify the whole lot. What was it? Channel. That's not correct, because this is what the trait expects. Cześć, tu gdzie? Pa. Oh, that's even worse typing. Because that's what it's not the embedded whole crate. It's the actual STM32F1 crate. And that expects what? 2F1XX. There it is. Steam RAM up channel. Is it? Yeah. And pin. So that's team 2. Team 2. Channel 1 and what was it? PA15 alternate push-pull type. Oh man, this is getting messy. GPOA A15. And team 2. And then we can use this. So PWM and delay. What's wrong with you? Yes, I know it's unused. Okay. So it's outside of our module, so that's why it is. That's outside of the module. And PWM. Can I just take it like that? Don't think so. Yeah, there's no way that's gonna work, because we expect owned PWM. Yeah. And what we're getting is just a mutable reference. And we will have the same problem with delay. Oh. Because with delay we're taking mutable reference. I won't be able to move. Or is that? Trade bound, blah blah blah, is not satisfied. Oh. Yes, that was to be expected. So we want, yeah. So we have a lifetime problem in here because we're dealing with the references, and we won't be able to move in here nor here. So that's it. So all we can do is just take a mutable reference here. But obviously then we need what's the syntax for that though? Like that. Prior. Ah, okay. So I guess this explicit lifetime required, that's correct, yes. Okay, so what is this now? Lifetime might not live long enough. Yes. So looks like we are getting into the callback hell. That we all know and love from JavaScript. Okay, so PWM. What is wrong here? Found unit type this. Do I need? Second mutable borrow occurs here. Okay, this is first mutable borrow here. Oh, we are borrowing the resources. Fuck. Okay. What was it here? Software task, resources. Each context handler. Oh, it's just that our problem is that we are working on the cutting edge stuff. Okay, what else we have here? Multi-lock, because that was also changed recently. That's what we need. Oh, look at this beauty. This is what we need. So we need PWM is and then delay. And what did they say? That it has to be mode. Yep. So then we just go boom, 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 and lock. So PWM and delay, and then lock, and then we can skip this bit, and we have this. Delay. No method. Why this doesn't work? Items from trades can only be used if the trade is in scope. Use RTIC core prelude. I will use it. Unresolved input. That didn't help. That's because do I need this? In that case, 0, 3, 1. And there it is. And it does not need to be mutable. Okay, let's clean this up then a little bit. So this, this, this. Cut song is fine. We don't need this. Okay, so we only have issue with this. Expected one argument. Why does Rust Analyzer think that we need just to see? And now it knows that it takes 0 arguments, but 1 was supplied. So it resolves it correctly if there's an error, but otherwise it gives you false positive, I guess. So like RTIC is heavily macro based, well, bunch of procedural macros. So that, I guess that just must be confusing the Rust Analyzer. Okay, let's check our stuff. Clean build. This. There. Let us hook up our super sound studio. My hard rocking amigo. There. Five volts. A15. And continue. And we get absolutely nothing. What did we do wrong? So again, resources, blah blah blah. This, we initialize it. We have the delay. New blah. Cut song. Oh, that's because I connected it incorrectly. I was defeated by too many cables. 3 cables is way too much that I can handle. Boom! Okay, let's stop it. Okay, I'm kind of happy with that. So this is our from little stuff here. That went pretty good. You can share the resources nicely. Way simpler code, because it is. It's in fact, it's well. There's a little bit of boilerplate when you need to make sure you're importing your libraries correctly. Sorry, your crates, your packages and stuff like that. But overall, it's way cleaner. You initialize your resources, and you just return it. So then you just specify the resources that you wish to utilize in each of the tasks, and boom. This is very cool, because I was afraid that you're going to be, you know, nesting all of this stuff. Although I'm not sure if this is all that good. Like, this is needed to satisfy the function signature. And that's where your actual code plays. But the problem with this is that if you were to change those values somewhere else, you wouldn't be able to, because that's constantly locked. So you're actually putting an infinite loop in your within your lock. But like, it's for this particular case. Probably there's other ways to do this. How you just do structure your code accordingly. Okay, I guess that'll be it for today. Jesus, 1 hour. Okay, bye bye.